Today, I'm going to go find the 100th smallest positive integer n such that it and its square begin with the same first digit. So I'm going to go start with the one-digit positive integers, starting with 1, because 1 squared equals 1. 1 does work, and I'm going to go mark that as the first positive integer, and that works. Now, 2 squared is 4. 2 does not work. 3 squared equals 9. 9 does not work. 4 squared is 16. And because 4 is not equal to 1, 4 does not work. And now I can go check 5, 6, 7, 8, and 9. And as you can see, this is taking way too long. I'm going to go need a more efficient strategy for that sprint problem. But I know some small squares, and I can consider the ranges. Like, I know that 10 squared is 100, and 14 squared is 196, and 15 squared equals 225. So I can look that 15 does not work, but 14 does work. And with those ranges thing that I've talked about, anything from 10 to 14 all do work. So that means an additional 5 ways. 16 through 19 will have to be more than 225, at least when you're squaring 16 through 19. But those squares all have to be less than 400, so none of the rest of the 10s do work. So now the 20s. The 20 squared is going to be 400. 30 squared is going to be 900. So the first digit of the squares have to be from 4 through 8, but the first digit of the 20s are only a 2, so none of the 20s work. And I think you can see for yourself that the 30s, 40s, 50s all similarly don't work. I don't have time to show that in the video. So now the 90s, because 90 squared is 8,100, and 100 squared is 10,000. So there may be a 90s that when you square, the first digit is going to be a 9. So 95, I'm going to go check that because it's right in the middle. That square is 9,025. That is just barely over 9,000. So I'm going to go need to check one below. I can go think clever and use some square chicken to see that this is 9,025 minus 190 plus 1. That's going to be less than 9,000. So 94 does not work. But with the ranges strategy, I can see that 99 does work. So that means an additional 5 values. But one more thing. 80 squared is 6,400, but 90 squared is 8,100. So there may be an 80s that when you square starts with an 8. Gotta check 89. That's 8100 minus 180 plus 1. That's going to be 7921. And no, that's first digit is not an 8. So I think I'm done with the 2-digit cases. Only 11. Time to do the 3 digits. I can build on the 2-digit cases and eliminate a lot of those middles because I can see that they will all not work without having to do some multiplication. And then also I can see that that I can find some working values 3-digit that do work. So after finding 140 squared, I'm going to need to check some small values above 140 squared, like 141. Because rather than do some multiplication, I'm going to go use another of those square strict. So that plus 280 plus 1, and that is going to equal 19881. That does work, but what about 142 squared? I really don't want to do any 3-digit multiplication. Unfortunately, I don't have a calculator on hand because it's a sprint round. So thinking of those squares, I see that you add 281 to 140 squared to get 141 squared. And thinking of those odd numbers, I remember something about odd integers adding them up to get squares. So if I add 283 to 19881, I can see that this is going to be more than 20,000. First digit is going to be a 2. That does not work. So I can round up an additional 42 working values of n. Now I can see, I'm going to need to try 890 because 89 squared is 7,921. So I'm going to have to go do 895 times 895. I'm going to go have to do this 3-digit multiplication. Hey, look at that. 895 does work. But I need to check 894 just in case. I don't want to do it again, but using these odd integers and squares relationship, I can see, hold on, 895 times 2 is 1790. So if I subtract 1789, the resulting number will have a first digit that is not equal to 8. So 894 does not work, but 899 does work. So that means an additional 5 values. Let's go. So now I'm going to go check the 900s. I know 950 does work. 902,500 as the square. Now I need to check 949 squared. Using that same odd integers and squares notes, I can see that doing some subtraction is going to get 900,601. That does work, but 948 squared, if I do another of the subtraction, that is going to be less than 900,000. So first digit is going to be an 8, no dice. And so this means I can round up 949 and 999 as working values for a total of 51. And now what's left is to find the 100th because I think I found some enough. So if I look, 899 is going to be the 58th integer. And so this means that 950 is going to be the 60th integer. And this means that 990 is going to be the 100th smallest positive integer, n. So this is answer choice D in that sprint round.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.